On the first anniversary of the outbreak of the war, so in 1915, the cosmopolitan Swedish chemist Svante Arrhenius, who was a grand master of international game of awarding Nobel Prizes, looked south from the security of neutral Sweden and despaired. Scientific internationalism, he wrote, is bankrupt. Many of those who had embraced it most warmly had repudiated it with the first fusillade of Nobel's smokeless powder in Belgium. It would not be so bad, so Arrhenius said, if only humanists and social scientists had acted so wretchedly. What shocked him was that physicists and chemists fell as easily for nationalist propaganda as ordinary people whose minds had not been fortified by the laws of thermodynamics. Natural scientists fancied themselves not only free from the prejudices that led the common herd to accept false prophets, but also under obligation to combat jingoism, that is, extreme nationalism. As Emil Fischer wrote his fellow Nobel Prize winner Paul Sabatier 2 years before the war, if political interests separate the peoples of Europe from one another, then we men of science have all the more right and duty to emphasize how much beauty is common to all civilized nations. The Solvay alumni, as I'll call the participants in the 2 pre-war physics councils, and also the chemists who angled with Solvay for support for their own enterprises, had perhaps a slightly better record than the physicists and chemists in the belligerent countries as a whole. But on the average, they did, but if on the average they did resist the worst excesses of the Trahison d'éclair, they came to do so gradually. For in the first rush to the colors, in the fervor of national unity, they were, if anything, more zealous than the rest. Being leaders in their discipline, they had more occasions to expose themselves in public and felt greater pressure to do so than the rank and file. Also, because they were leaders in their disciplines, that is, the Solvay alumni, many of them were nominated for the Nobel Prize during and despite the war. Fully half of the 34 alumni received nominations. Half of the people who had attended the Solvay conference before the war and the chemists who tried to promote themselves were nominated for prizes during the war, and 3 of them won. William Henry Bragg, Max von Laue, and Max Planck, all of whom were invited to join the other wartime winners in a special ceremony held in Stockholm in June of 1920. If the Swedish hosts expected this get-together to help reestablish peaceful relations among scientists of the former belligerent powers, they soon realized their error. The event in Stockholm in the summer of 1920 demonstrated the continuance of wartime animosities and exposed deep political divisions among the members of the German contingent and within the Nobel establishment. So, my talk today describes the various ways in which the Solvay alumni participated in World War I and ends with remarks about the revealing and dysfunctional celebration in Stockholm in 1920. So here is what is to come. First, war work, to the front, then back from the front on the part of the younger scientists, then a little about science as usual as practiced during the war, and finally this dysfunctional party in Stockholm. So, to work. Propaganda. The German Solvay alumni did not hold back from signing this famous Anruf, or appeal of the 93 intellectuals, which in effect charged Belgian citizens with causing their own deaths and the destruction of such monuments as the library at Louvain. According to the appeal, or as it is usually referred to in English as the manifesto, German troops had fired on civilians only after grievous provocation. Had the Belgians behaved themselves, as directed by the well-disciplined, culture-loving invaders, they would have been treated with the courtesy the German army constantly shows to people lucky enough to be conquered by it. But no, the perfidious Belgians had fired on the invaders. The forbearing Germans replied in self-defense. It was too bad about the Louvain library, but as they said, we will not purchase the preservation of works of art at the price of a German defeat. No one could doubt, the 93 intellectuals continued, that German professors set a high value on European culture. So necessarily did the German military, for, and I quote, the German people and the German army are one. And so their appeal, to you who know us and have like us been custodians of the most precious possessions of humanity, we cry, believe us. Believe that in this fight we shall go on to the end as a civilized people, a people for whom the writings of a Goethe, a Beethoven, and a Kant is as sacred as hearth and home. 4 of the 11 German Solvay alumni, Walter Nernst, Wilhelm Ostwald, Planck, and Wilhelm Wien, signed the manifesto. Here it is in the passages that I have just read to you. The numbers certainly would have been higher if all of the 11 German alumni had been asked, for over half of them were by sentiment, if not by signature, adherents to the manifesto, even though they had enjoyed Solvay's generosity a year before it was issued. It was especially distressing for him to see the names of Ostwald and Nernst, for their owners had enjoyed his confidence for many years. Ostwald had welcomed Solvay's political and economic ideas and had often visited Brussels to learn from the man he styled the founder of social energetics. Ostwald's student Nernst had engineered a medal for Solvay from the Berlin Academy of Sciences and collaborated with him in inventing and calling the first and famous Solvay Congress or Council in Physics. British academics replied to the manifesto in an open letter to Nature, which expressed admiration for German science and a stupefaction that German scientists had not been able to discern that their government systematically lied to them. And then, having come so far, the Brits ruined the effect by charging Germany with intentionally bringing on the war. The signatories included one alumnus, J.J. Thomson, and in a similar letter in the London Times, Thomson was joined by William Henry Bragg, William Ramsay, and Lord Rayleigh. French and English propagandists replied to the German claim to culture that Germans in general had produced nothing of high cultural value. Goethe and Beethoven and Kant were unrepresentative flukes, sports of nature. According to the Paris Academy of Sciences, Frenchmen and Anglo-Saxons had made almost all the great discoveries in science and most of the main inventions of the 19th century, to which the French Physical Society added the crazy confirmation, and this is particularly true of physics. A luxurious literature grew up to prove German incompetence in science. The most inventive Englishman in this unpromising line was the chemist Ramsay, who had a German doctorate in chemistry and had been a close friend of Ostwald's before the war. According to Ramsay's careful calculation, Germans had no originality. They exploited without inventing, compiled without judgment, and plotted on command. Their civilization, indeed, and their military were but one. Pierre Duhem, professor of physics at the University of Bordeaux and the world's leading expert in medieval science, followed up Ramsay's initiative masterfully. The Germans, he wrote, take obscurity for profundity. They proceed brutally that is, systematically, and are the happier, quote, the stranger and more revolting the outcome. For him, the exemplar of Teutonic barbarity in science was a theory of relativity of alumnus Einstein. Why then did everybody before the war think that the Germans were the leaders in science? Ramsay had the answer: organization. They had industrialized scientific production, replaced inventiveness by competence, and genius by systematic education. Thus, they dominated academic publishing and supplied the world's scientific instruments and high-tech devices. But stripped of its Zentralblätter and Jahrbucher, its vacuum pumps and Jena glass, Germany would sink to its rightful place among the secondary scientific powers. Ostwald responded to this belittlement by observing that the British and the French were so mired in individualism that they could not even conceive the cultural program that underlies organization. So he accepted the charge that the Germans' expertise relied on organization. That is, organization in the Germanic, that is, once again, the organizational concept of culture. Lacking this conception, Entente scientists had no soul. 16 physicists, including Sommerfeld and Wien, went on to warn against the moral contagion contracted from reading British physics and insisted that their colleagues employ the proper prophylaxis against it. That is, not to read any scientific publications coming from England and not to cite them if you could avoid it. They tried to enlist the Berlin Solvay alumni Planck, Heinrich Rubens, and Warburg in this campaign, but happily failed. Some advance was made in the field of comparative disparagement by Charles Richet, who won the Nobel Prize in Physiology in 1913 for his work on sensitivity to poisons, certainly a good introduction to the field. Richet pointed out that the literature in his particular specialty in French and German divided exactly in proportion to the populations of the countries. It would be sacrilegious, he went on, and absurd to deny that Germans had played a major part in science, although, of course, they could not boast the equal of a Lavoisier or a Pasteur. It took a neutral American, the Harvard astronomer Edward Pickering, to remove these last vestiges of nationalism. Considering only scientists who were foreign members of at least 2 of 7 of the world's leading scientific academies, he found that the Central Powers had 40 such overachievers with an average of 4.27 memberships each, whereas the Entente had 41 demigods with 4.41 memberships each. That was in 1915. So the contending sides turned out to be as equal in great senior scientists as they were, for the moment, on the battlefield. I come now to my second subject. What do you know? Have I got myself? There we go. To my second subject, when the scientists came back from the front. I've spoken to you about propaganda only because that was what involved the Solvay participants, since they were too old to fight. It was the younger men, of course, who went to the front. Well, one cause of the vituperative propaganda invented by senior scientists was frustration. Being too old for armed conflict, they vented it by calling their former colleagues names. Several of them, however, did shed their blood, if only vicariously. The hardest hit were Nernst, both of whose sons died on the battlefield, and Planck, whose toll was his elder son, his nephew, and his younger son, who was not killed but wounded and taken prisoner by the French. On the Entente side, Bragg lost a son, and perhaps others did too. But given the age profile of the alumni, only a few saw active duty, notably Marie Curie, who drove an ambulance, as is well known, at the front. Well-known picture. And Fritz Ozernöhrl, the best of Austria's theoretical physicists, the natural successor to Boltzmann, who died in battle. The initial mobilization almost emptied the universities of students and young professors. In Germany and Austria, almost all the junior staff of the physics institutes went to war in combat roles. The student body of the German Technische Hochschulen, taken as a whole, fell from 12,000 in the summer semester of 1914 to 2,000 at the end of the fall semester of 1914. The entire entering class of the École Normale Supérieure in Paris rushed to the front, as did most of the older boys. Of the 240 who enlisted, 100 were killed and 80 wounded. Total enrollment in French universities declined by 75% in the first year of the war. In Britain, Oxford and Cambridge became ghost universities. 90% of the students left, about 70% directly to the front, usually as officers, where their survival was reckoned at 30 days. You see, it was hard to resist the propaganda to enlist. In a sickening version of the Erasmus program, the university students of Europe thus had and took the opportunity to meet and match wits with their opposite numbers from other countries on the battlefield. In the summer of 1915, the Entente powers realized that they needed scientists to make substitutes for strategic and high-tech items previously imported from Germany, like optical glass for binoculars, telescopes, and periscopes. I have a few examples here of such optical munitions, and most important of all in that trench warfare, an ability to see over the trenches. Both sides understood that the longer the war lasted, the more important technology would be on the battlefield. Poison gas, U-boats, airplanes, long-range artillery, wireless communication, and countermeasures to all of these required for their development and deployment the technically trained university men being squandered in the trenches. The authorities withdrew physicists from the front to join Solvay alumni prosecuting war work at home. For example, on the German side, Lauer was working with Wien on amplifying tubes for radio communications. And here are a few indications of the way in which radio was employed, or people tried to employ radio during the war. Here is another example. I don't know if you can see things. Can the lights come down even a little bit more? And finally, if all failed, one could resort to the old style of communication. And to return to the collaborations during the war, Nernst worked with Fritz Haber on chemical warfare. Bragg, Ernest Rutherford, Paul Langevin, Jean Perrin sought ways of combating U-boats. Frederick Lindemann, an Englishman despite his name, tinkered with airplanes. William Pope improved plates for aerial photography. J.J. Thomson, as president of the Royal Society, worked to organize scientific manpower and direct it effectively. And when not driving around on her X-ray machine, Marie Curie attended a Comité des Corps Radioactifs with the precocious assignment of finding the best applications of radioactive materials to the needs of war. In organizing scientific manpower to recreate German industrial processes or devise weapons for battlefield use, the Entente spokesman for science forgot the fiction that their enemies had accomplished nothing valuable or imitable in science. Britain depended on German imports to start their land vehicles and airplanes, explosives for its artillery, dyes to distinguish its army uniforms from its navies, medical supplies, and all sorts of laboratory equipment, from centrifuges to filter paper. To win the war, the British would have to swallow hard and guess what? Organize, or to quote one of the mobilizers, make a disciplined army of scientific workers from a mob of independent-minded civilians. The new army of science would have privates doing prescribed work directed by a general staff composed of fellows of the Royal Society of London, acting under the generalship of their president and commander-in-chief, alumnus Thomson. The French deployed the same rhetoric to the same purpose. As late as 1916, the land of Lavoisier could not manufacture medical thermometers. To overcome this and other strategic needs and embarrassments, so the rhetoric ran, Frenchmen would have to surrender their exaggerated feelings of individualism. Their independence of spirit had ruined French industry and reduced the competitiveness of French science. Doing as the enemy did, coordinating, cooperating, and, yes, organizing, the French learned how to make thermometers, and also glass apparatus, binoculars, X-ray tubes, thermos bottles, photographic equipment, chemical dyes, and so on. With the British, they developed techniques for locating enemy artillery so quickly and accurately that they could knock out batteries within a few minutes after the first shots had been fired. It turned out that in devising and routinizing this technique, in which the sons of Bragg and Thomson played leading parts, the Entente far outstripped the Central Powers. The Entente proved to be far better at organizing to meet new emergencies than their enemies. But there are other things going on in the war. Two quite different enterprises fall under the head of business, almost as usual. One is the continuation of scientific research along pre-war lines. The other is a gesture towards a return to normal relations among scientists. Solvay alumni from neutral countries, Martin Knudsen from Denmark, Heikki Kamerling Onus and Lawrence from the Netherlands, and Pierre Weiss from Switzerland, could carry on their work the more freely with the virtual removal of competition from the scientists in the belligerent countries. All of them, the men I just mentioned, received nominations for the Nobel Prize in Physics for this work, except Kamerling Onus, who had won in 1912, but not excluding Lorentz, who had won in 1902. But belligerent physicists also accomplished work of the first importance. Here, Rutherford, Sommerfeld, and Einstein each made contributions that could have won them a Nobel Prize. Rutherford managed to squeeze out enough time to become the first man to provoke a nuclear reaction intentionally. He found that fast alpha particles could liberate either hydrogen nuclei or some otherwise unknown particles from nitrogen nuclei. Thus, the problems of nuclear structure and transformation entered physics just after the war, when Rutherford published these and other results he had obtained occasionally during it. In contrast, Sommerfeld did war work only part-time on radio communications with submarines and airplanes, and on gyroscopes for steadying the flight of heavy artillery shells, none of which had the least practical value. He also kept a peacetime research schedule with the help of detained foreign students from Poland and Russia. He thus built up Bohr's quantum theory into a systematic account of atomic structure, and atomic music of the spheres, as he called it, in his textbook Atombau und Spektrallinien, from which all demobilizing physicists, whatever their language or nationality, had to learn or relearn the foundations of their subject. Einstein also had succeeded in working relatively unmolested, despite his outspoken pacifism, and he completed his general theory of relativity in time for testing by the solar eclipse of 1919. Since the prostrate Germans were in no condition to mount an expedition to far places, the test fell entirely to a British team led by or inspired by the Cambridge astronomer Arthur Eddington. With some difficulty and to some approximation, the pacifist English Quaker confirmed the super pure theory of the pacifist German Jew. It was a hopeful sign. It would take almost a decade, however, to restore pre-war international relations among scientists less inclined to peace and purity than Einstein and Eddington. Solvay alumni who worked most effectively toward reintegration were Lorentz, Einstein, and Planck. They had started the good work during the war, Einstein through his opposition to German militarism, Planck and Lorentz through their attempts to prepare the ground for post-war collaboration. Planck began to doubt the truth of the claims of the Manifesto of the 93 not long after he had signed it without reading it. Correspondence with Lorentz, whom he trusted, persuaded him that the German army had committed atrocities in Belgium. There are the protagonists about the time they interacted. In a courageous act, alone of the 93, Planck publicly repudiated the Manifesto, and in terms from which, on Lorentz's advice, he had removed all recriminations. Planck had in mind as his principal audience his fellow Solvay alumni, and he asked Lorentz, who could send letters in all directions from Leiden, to be sure that all his former colleagues received a printed copy of his retraction. They should have been stirred by the final passage. There are dimensions of institutional and moral life that lie beyond the struggles of nations. Honorable cooperation in the cultivation of these international cultural values and not less personal respect for citizens of enemy states are indeed compatible with ardent love and energetic work for one's own country. This sentiment fit perfectly with Solvay's practice of combining the roles of international sponsor and Belgian patriot. Planck's words must have cheered him, for the manifesto, or the appeal, coming from scientists he had respected, had distressed him. Planck's deeds no doubt cheered him more, for in cooperating with Warburg, Planck helped to alleviate the treatment of Solvay and his collaborators during the German military occupation of Belgium. And now I come to the party in Stockholm. The first of the wartime prizes in physics went to Solvay alumni, to Lauer in 1914, and to Bragg and his son, not the one killed in the war, in 1915, for their work on the diffraction of X-rays and on crystal structure. The parallel prizes in chemistry went to a Harvard professor, Theodore Richards, who has been a student of Ostwald's, for his measurements of atomic weights, and to Richard Willstätter, a close colleague of Haber's, for his research on chlorophyll. These awards, which were announced simultaneously, since the Royal Swedish Academy of Sciences decided not to give prizes in 1914, so all the four were announced in 1915, were widely accepted as even-handed and appropriate. In 1916, the Academy again withheld prizes, and since neither of its prize committees could find a worthy recipient for 1917, although Planck and Einstein still had not got prizes, the money stayed in Stockholm because, according to a perverse provision of the Nobel Foundations, if a committee fails to find a winner in 2 years running, it gets to keep the premium, that is, the prize. In 1918, Chemistry, failing again to find a nominee, pocketed its prize for 1917. The physicists found Charles Glover Barkla, an Englishman nominated by Rutherford. In case you're having trouble keeping these guys in mind, here is the list. Barkla had classified X-rays qualitatively in a way that proved useful to the Braggs and to Rutherford's prize student Henry Moseley, who had run to the colors and was killed in 1915. In my opinion, Rutherford put up Barkla as a stand-in for Moseley, who had been nominated for the prize already in 1915 before his death. As for the physics prize of 1918, the wise men of Stockholm at last agreed to give one to Planck. And to finish the account, in 1919, the chemistry committee put forward Haber for its deferred prize of 1918, but made no suggestion for the current year, while the more generous physicists agreed on Johannes Stark, the first man to split spectral lines with an electric force. So, as you see, and in fact, as you heard last night, between 1914 and 1919 inclusive, the Swedish Academy gave 8 prizes, 5 to Germans, and 3, 5 in physics and 3 in chemistry, 5 to Germans and 3 to Anglophones. In fact, 4 to Anglophones if you count the Braggs as 2. All 9 winners were invited to an exceptional award ceremony in Stockholm in the summer of 1920. All the Germans accepted. The English speakers, seeing themselves outgunned by their recent enemies, stayed away, except for Barkla. Richards could not come, he said, because of the distance and because he refused to have anything to do with people who could sign the manifesto of the 93. The Braggs proffered the curious excuse that picking up their Nobel Prizes would interfere with their teaching and stayed home. Only the blockhead Barkla attended the party in Stockholm, not anticipating that the Germans would make it the occasion to celebrate their science and the unbiased assessment of scientific achievements by their hosts and only friends, the Swedes. The focus of interest, of course, was Haber, who attracted attention not only as a quasi-war criminal, but also because, in fact, he was a jovial character. There you see the two unevenly matched people, poor Barkla and confident Haber. In justification for his war work, Haber pointed to Archimedes' legendary feats on behalf of Syracuse, and also, of course, to the Nobel Prize, the award of which showed that he had done nothing blameworthy in the eyes of the neutral and cosmopolitan Swedes. Stark echoed the theme. The Royal Swedish Academy of Sciences had not let political considerations influence its judgment when awarding the 3 prizes of 1918-19 to Germans. And there are the prize winners in on their stamps. Barkla joined the praise of German science and Swedish impartiality. The German ambassador reported the good news to headquarters. The entire business, he wrote to Berlin, was a sort of homage to German science. Solvay alumni Laue and Planck did not join in this jingoism. The German press described the party as a Deutscher Sieg. What a victory of the German spirit and an augur of the future. The French press rated the party revolting, and the Swedes anything but impartial. The newspapers concluded that the Swedes were still enthralled to Germany, that Haber's prize was a scandal, and that Barkla's conciliatory speech nearly as bad. The Germans took away the lessons that a special bond existed between them and the Nobel committees, and they tried to exploit it. Thus, in 1923, Haber and Willstätter tried to stop the Academy from awarding the chemistry prize to Fritz Pregel. And Stark's close ally and fellow Nazi Philipp Lenard, the physics prize winner for 1905, protested against giving a prize to Einstein. Haber and Willstätter, both Jews, opposed Pregel, an Austrian, because they thought his contribution, which was quantitative microanalysis of organic material, more laboratory technique than fundamental science, and worried that the award would lower the prestige of Nobel Prizes in Germany. Stark and Leonard opposed Einstein on pure grounds, that is, purely anti-Semitic grounds. But Leonard also allowed himself to express a sense of betrayal by the Swedish Academy. It had not been able to summon, so he said, enough clear German Geist to avoid such an error as to promote an Einstein. The wartime prizes meant much to the German recipients. Laue used his prize to fulfill what he took to be his duty to his country and invested it entirely in war bonds. This is the sort of propaganda to which they were subjected, to give money for the war, and should not leave you with the impression that it was only the Germans who had such nice posters. Here's one from France. Willstätter and Planck received their prizes at times of personal despair, which the recognition did something to alleviate. As I mentioned, Haber considered his prize full exoneration for his war work. Stark used his to resign from his professorship and raise his political voice. Giovanni Fortissimo, as Einstein called him, continued to take pride in being one of the 93 and one of Hitler's first supporters. I come now to the end. In 1924, Willstätter also resigned his professorship, but as a protest. He could not remain on a faculty that acquiesced in an anti-Semitic vote engineered by alumnus Wien, whom Haber regarded as a more dangerous enemy of the Jews than Stark. Here is Wilhelm Wien. Haber resigned his academic positions in 1933 after refusing to fire his Jewish colleagues and employees as required by the Nazi law for the cleansing of the civil service. He died in 1934 in Switzerland. Planck and Laue courageously held a public memorial service for him, despite strong opposition from the Nazis, who ejected Planck from his various offices a few years later. Einstein, who was in California when the Nazis came to power, resigned his membership at the Berlin Academy of Sciences before its secretary, his good old friend Planck, would have had to force him out. The British, in their insularity, did not place much importance on the Nobel Prizes. Henry Bragg never went to Stockholm to collect his certificate and give the required lecture, despite repeated invitations. His son, Lawrence, discovered the significance of the prize in the eyes of others only when he thought himself sufficiently free from teaching to attend an awards ceremony in Sweden. He was then working successfully into his position as Rutherford's successor at the University of Manchester. As for Barclay, despite his honors, he drifted to the fringes of physics in an effort to establish the existence of a species of X-rays no one else ever detected. There is no escape from the conclusion that Nobel Prizes are in part motivated by considerations not entirely scientific. That's because there are always more worthy candidates than prizes. Decisions about appropriate fields for awards, the sequence of the prizes, the felt need to not to favor one country unduly, the personalities of the Nobel Committee members, pressures from the scientific communities, and so on, inevitably influence choice. No doubt politics of a lower sort may help explain such anomalies as the neglect of Sommerfeld, who was nominated every year but one, from 1917 to 1937, frequently by Planck and Laue, once by Wien, 69 times in all. Most of his support came from the Central Powers at a time when the Swedish Academy, embarrassed by the fiasco of 1920 and cognizant of the permanent shift in the balance of power, realigned toward the Entente. Was that the reason that Sommerfeld's fellow alumni, like Einstein and Lawrence, who knew his work well, did not nominate him? Or Nernst, winner of the Nobel Prize in Chemistry in 1921? Or Niels Bohr, who joined the Solvay Committee at the First Council to meet after the war in 1921 and joined the Nobel Prize winners with their right of perpetual nomination in 1923? Between 1920 and 1935, Bohr made 23 nominations for 11 candidates, all but one of whom, the American alumnus Wood, received a prize. Had Bohr supported Sommerfeld, he almost certainly would have succeeded. But Sommerfeld's approach to physics and to life was different from Bohr's. The first post-war Solvay councils excluded citizens of the Central Powers apart from Einstein. But in 1927, with Lawrence still its president, the Solvay Institute for Physics invited Planck to attend that year's meeting. Planck considered the invitation to be politically motivated because Sommerfeld, who knew the subject of the meeting better than he did, had not been invited. But Sommerfeld had advocated the annexation of Belgium, and Planck had done what he could to help the Belgian cause. Therefore, Planck decided not to go to Brussels. Once again, Lawrence set him right. Whatever he did, whether he attended the meeting or not, he would be making a political statement. The choice was whether to express solidarity with the nationalist Sommerfeld or faith in internationalism with Lawrence. Planck went to Brussels. The same year, he attended a grand international congress of physics held at Como. He had not burdened his conscience in deciding to go. He had not considered that the meeting was a propaganda extravaganza of the fascist government and that Mussolini would claim the presence of so many distinguished physicists as an endorsement of his regime. It is often impossible to scrape extra scientific consequences from decisions about science. There may be no purely scientific course of action. Values enter. This is not a bad thing if your values agree with mine. Thank you for your attendance.